All right. I'm meant to be presenting this with Adam Anderson, my good friend and co-worker. However, he got held up in Chile for some extra time. So he's not landing in Perth until 9 o'clock tonight. So here I am. It's just me. But Adam deserves a lot of credit for this work as well. And we're pretty excited about what we get to share. So I'm going to jump right in and we're going to talk about Marvel Loch. And I tell you what, I never thought drilling out kaolin could be quite so exciting. So we'll start with an overview. Kula Gold, we're a small explorer in Perth, and we just look for whatever the ground's going to give us. So we hold several projects within the Southern Cross region, and they were all pegged on Adam's generative work. And I'm pretty grateful to have the opportunity to work on them because they're quite exciting. So E772621 is the one with all the black labels coming off in the southeast corner there. And that was our flagship tenement for the Marvel Loch Airfield project. So if we just talk about the regional geology quickly, it sits within the Kula Dome, and which is a part of the Big Bell Suite. And the literature describes it as commonly foliated metagranite, which includes granodiorite to monzogranite. And I sort of delved a bit deeper in, and you can just see what I've highlighted there. There's granitic rocks within the suite may contain megmatitic enclaves ranging in composition from granitic rock to amphibolite. And down the bottom, the typical description says the middle to upper amphibolite facies tectonic foliation is commonly present within this granite, but mostly along the margins of the dome. So domes give a magnetic low signature relative to the high magnetic response of the greenstones around the outside. That's pretty standard knowledge. But when we look at the 1VD, which I've just put underneath there, there's little subtle features and trends you can see within there, which, you know, who knows what that is. The greenstone belt surrounding the Kula Dome hosts many gold deposits and occurrences. So that's just the Mindex occurrences for precious metals plotted on there. And there's the other commodities. Relatively speaking, there's not many deposits within the granites. And that's reflected in the location of the operating mines, because if we're exploring the greenstones, not really the granites, that's where the mines are. And there's the tenement pegging as of Friday, mostly clustered around the greenstones. And that trend is reflected across the whole craton pretty much. So there's the geology, the mineral occurrences, the operating mines, which there's very few in the granites, and the tenements. There's a whole lot of pink space there. So in an industry where many people strongly believe that all the easy to find shallow deposits have already been found, that most of the ground considered prospective, it's already pegged, and advancements in technology for exploration come with a pretty big price tag. As a junior explorer, we have to get creative to mitigate these challenges. So we just try and do things a bit differently. So if anyone's wondering what this has to do with Marvel Loch, I might get there eventually. Cautionary statement. I think that's a good one. All right, seriously, it's work in progress. I don't know all the answers. I'm not going to claim to. There's a lot of work that needs to be done. And to be fair, as a junior explorer, we're not in the business of the academic side, of doing the research, of writing the articles. Our business is to add value for our shareholders, and that's what we need to focus on to stay afloat. But what we do know is what we found doesn't fit the current known. And it's worth sharing because it could be a game changer. So let's start with a bit of a backstory. In 2019, this tenement was pegged based on work by Adam. He spent some time and he looked through the old GeoView and the WAMEX reports, and he came up with this. Had some interesting mag features. There was anomalous gold in auger completed by Sons of Gwalia between 97 and 99. It sits in a similar geological location as the Golden City's gold deposit. in the middle of a granite with a dike going through. And so we targeted it based on gold-bearing quartz veins along faults and shears within dolerite or granite. Seemed pretty straightforward. In 2020, Kula went out and completed auger at the CRAYFISH prospect, which was aptly named because of the magnetic response, which is kind of cool. And in 2021, we expanded that auger sampling, which discovered G-star in the bottom southeast corner. So to follow up the anomalism in CRAYFISH auger by SOG and our auger, which repeated some of that, we got a rig out to do some air core. But we quickly realised that the hard pan at the surface, the silcrete, was quite the pain to get through, and thankfully we had a rig that was actually an RC rig, so we swapped to RC. Just seemed smart. And everything told us, because looking at that, what rock types would you expect to hit? I'm going to go with granite and dolerite. Except we hit a lot of amphibolite. And yeah, it was quite a funny story. I was on the rig. Adam was getting the clearing sorted. He ran back and I'm like, Adam, this isn't granite. And he's like, what's wrong with you? If it's light, it's granite. If it's dark, it's dolerite. How hard is it? And I'm like, I've got 15 years experience. Don't you tell me I don't know what granite is. So I promptly called it not granite the rest of the day. And I took a lot of pleasure slamming that chip tray in front of Adam at the pub that night and went, how's this for not granite? And that was a pretty accurate representation of his face. It was actually really cool. It was a good moment. He was like, do you know what this means, Mel? And I'm like, I know, I've been thinking about it all day. So following on, I had to go home back to Perth following that night, and Adam finished up the RC holes and his mind was spinning. Where's the granite? What's going on? So on the last day of drilling, he took a punt and he moved the rig to investigate that subtle boomerang shape feature in the magnetics. We didn't really know what it was, but you know, how are we going to find out without a drill hole? So he collared BMRC1, which is the southernmost hole in the red there. And woohoo, we hit amphibolite. But so much kaolin. It was like, ugh. So Adam's going, how do I escape this kaolin? I know, I'll move the rig 200 meters to the north. So we did. But he hit more kaolin. So we moved the rig 60 meters further to the north and hit more kaolin and amphibolite and some felsics. The rig had to go to its next job because it was booked in. So off to the railway, where you go. And that's Mark's face telling Adam there's plenty of money to make in kaolin. Well done, team. So quick side story here. We're just going to go, we went, Kula, pretty proud of this one, discovery to deposit within a year. So it was July 21 when we got the assays that confirmed the purity and the quality of the kaolin. November 21, start the drill program. We finished that January 21 because obviously December, January, everyone's on holidays. We had to do over 3 blocks of drilling. But we got it done. February to March was data prep and loading it to the database. Now I have to give a shout out here to GDB, a database company, because when I went out to Boomerang, I had a team. Adam was overseas in Chile just before this program started. He left to go to Chile and he's like, you got this, Mel. And I'm like, okay. So I took a team out of 2 geos and 5 field assistants, and the 2 geos were oil and gas geos and they did a good job. And the 5 fieldies, none of them had ever seen a rig before. So as the person that was supervising this program, I was like, okay, there's a lot to consider and there's a lot of things we've got to work on. So one thing I didn't want to have to worry about was the data capture, and GDB made that a very, very smooth process for us. So with capture sheets and codes, and just made it simple. So thanks, guys. So then in March, up rocked the diamond rig for the network drill holes. And then we got the results back, and GDB made that easy as well, because they just sent me an export once they'd loaded all the assays in straight from the lab reports. And I spent a day checking the geology codes and everything. And the moment I sent that through to the resource geo, whew, what a weight off the shoulders. That was actually me walking out the door that day. And I just have to point this out because I'm proud of this one. No significant errors were identified in the data set that I sent through to the resource geo. Yes, nailed it. So, you know, at Kula, we've moved on to the next exciting project while we wait for Steve to work his magic. And Peter Hayward from Sedgman, he did his Met stuff, and they did their resource thing May through June, and it was July 22 on the 20th that we announced the maiden resource of 93.3 million tonnes of kaolinised granite. 60 years mine life, not bad for less than $1.2 million spent. At Kula, we like to add value for our shareholders. So, if anyone got lost, we're about back to the main story in my how I tell a story. All right, after we discovered this amphibolite in the April drilling, we went, yeah, maybe these mag features, subtle features, have something else going on. So we had the public available mags reprocessed, and this is a tilt magnetics version, but we got a few other versions, but this one, things really stand out. So we basically, I believe, stretched the histogram or whatever the geophysicists do to bring out the features in the low mag zone. Sorry, geophysicists. At the time that we were thinking about how to develop crayfish further and what it meant and, well, what is going on there, we thought, you know what we need? We need diamond core. We need to see this rock as rock, not as chips, because it's a bit hard as chips. So in November 21, at the same time as the drill program, in fact, I looked at the plots. It was 1 year ago today that that first hole was collared. So we designed 3 diamond holes. Well, actually, we designed one, and then the other 2 I designed on the fly based on what we saw in the first one. And that was because we needed to understand what the rock looked like down hole. So the first 2 holes were drilled up near the RC drilling, and the first one we re-entered we did a diamond tail on an RC hole. And yeah, we got some rocks that were quite interesting, and I tell you what, confusing. So the drilling intercepted variably silica altered gneissic amphibolite with abundant pegmatite veining. And the pegmatite veining was quite spectacular, actually. This beautiful garnet altered amphibolite with abundant quartz and pegmatite veining through it. And I was blown away because we're in amphibolite facies metamorphism in the middle of a granite. And I thought, what are these garnets doing here? And holy crap, if there's garnets, that's not a good thing for gold normally. I'm in the wrong metamorphic grade. But we also hit this, what I thought at the time was a silica flushed amphibolite with some trace sulfates, like 1 to 2% disseminated pyrite and chalcopyrite through it. And I say that because there was no feldspar in it. So it can't really be a granite if there's no feldspar. So I'm like, well, okay, how else do I describe this? Looks, got the amphibole minerals, amphibolites were around. I'm just going to say it's been silica flushed. Kind of made sense. So the the second hole we drilled, I just pivoted to the south west from the first one, just because the first one sort of drilled down the fabric and I wanted to drill through it, which was the purpose of it because we didn't understand what the fabric was doing at the time. And so I had another drill hole and I thought, well, we've already sort of figured out that northern area. So these interesting fold-like features resolved in the magnetics down here could be worthwhile drilling. And in these holes, we hit like what we'd more commonly recognize as amphibolite. And there was fracturing, abundant quartz veining, and patches of weak silica alteration. There was thicker, multi-stage, coarse-grained quartz veins with evidence of brittle ductile deformation and a sheared brecciation fabric. A lot of broken core. There was pegmatite veining with felsic to intermediate composition. There was visible evidence of folding within the amphibolite unit. And this blew my mind. There was not just one, but two separate fold events apparent in the core. So what results did we get? Well, I'm just going to caveat this. I got the multi-element last week because we in-house PXRF'd it. So done a lot of work this week. But we got a coincident tungsten moly enrichment in the first hole. In fact, we got a screaming moly anomaly. We got 0.8 meters at 223.5 ppm, which are, for exploratory exploration, it's nothing to be sneezed at, really. And that correlates with this garnet-bearing amphibolite, which was cool. In 21 CYDD1, which, so I've just tilted the cross section, so we're looking northeast now. We got moly enrichment as well, and we got 0.8 meters at 132, and again in the garnet bearing amphibolite. And in I forgot to move the section line, sorry, my mistake. In the bottom hole, so in the foldy bit, we got a couple of zones of coincident copper, nickel, cobalt, platinum, palladium values. I consider them interesting, but as I said, I got the multi-element a week ago. And we need to do a bit more work to understand these values in the context of the geology that they sit. So, the interp's under construction, as you can see with my little symbol there. But of course, at the time we drilled out Boomerang, 5 days after the diamond drill started, we had none of this info. And here we are, I think there was 4 geologists at the time, standing around the core just going, what the heck are we looking at? This does not make sense. So it's just confusing. But roll on the RC drilling. We've got a kaolin deposit to drill out. So Boomerang RC, November 21 to January 22. We did just over 5,000 meters in 78 holes. 24 days of drilling in 3 separate blocks, and we covered almost 3 square kilometers. We intersected kaolin, you'd hope so, and a lot of it. The purest white gold there is. Amphibolite, typical form as we all know it, but not a lot at Boomerang. We didn't hit a lot of this standard amphibolite. We hit this intensely silica flushed amphibolite with trace sulfides, and that's what I'm calling it because I don't know what else to call it. It's got amphiboles, biotites, silica, no feldspar. Could be some form of intrusive though. It doesn't look like an amphibolite. There's no feldspar. So weird. So in 1 or 2 holes, we did actually hit a granitoid, and at 80 holes into the drill program, by the time we hit it, I was like, is that feldspar? It can't be feldspar. I haven't seen any feldspar aside from the pegmatite. And we hit a lot of pegmatite, So trying to understand this in the context of everything at the time was, but we're getting there. By sort of the last block of drilling, I had an idea in my head of what could be going on. But I think the last week, I don't know. A lot of work needs to be done. We also hit this, which was super exciting. Silica sericite fuchsite alteration with abundant arsenopyrite in what I'm going to call not granite. I was pretty excited to hit this. It was green. I remember taking the photo at the top and sending it to Adam, who was in Chile, going, what the F? I'm so confused. And he was just like, that's good. That's a good sign. Keep drilling. And I was like, yes, keep drilling. Okay. So we drilled till we ran out of rods. So what did we get from drilling? Well, aside from a 93.3 million tonne kaolin resource within a year, under 1.2 mil spent, well done team, we got intercepts for gold. Introducing Ballantine White Gold Prospect. We got 1 metre at 2.67 grams per tonne in the middle of a granite. So I'm pretty excited by that. And kicking back to cutting my grass in Cambelda, the prospect's been named after the drillers Ballantine White. We also got, coincident, copper, nickel, cobalt, platinum, palladium in the hole right next door. And that hole got bogged in smectitic clay. And at the time, I remember this was hole 23 in 2021. So it was the 20th hole we did in that program. And I went, we're through the kaolin, let's move on. I don't want to risk getting bogged. Seemed like the wise decision to make at the time. In fact, there are other interesting copper, nickel, cobalt, platinum, palladium values floating around. So this is a cross section through the top there, and you can just see in the, so small on the screen, sorry, in BMRC2, we've got a couple of values, but, you know, not really enough that I can tie together to make an intercept or whatever, but, you know, it doesn't really match a granite. We also got, we've moved down to sort of, I'm going to call it the hinge of the Boomerang feature. We got some hits there. So we're looking at the Ballantine White, gold, and copper, nickel, cobalt, platinum, palladium prospect. Because that would be cool. But how do you get copper, nickel, cobalt, platinum group elements in a granite? So I made a little video. So if I review this spatially, you can see that those values are associated with that magnetic feature. So in this, I've just turned off all the grades and filtered for anything over 75 ppm nickel, or else it was just, you couldn't see anything. But I think it's pretty clear that you get that anomalism or enrichment. Enrichment's probably a better word, or values around that boomerang shape. So what rock's giving this boomerang shaped magnetic response? And what could possibly be responsible for all the subtle features we see in those magnetics? Wonder if there's any clues in the geochem, which I got last week. So fair warning, I'm no geochem expert at all. In fact, on the scale of hobbyist to expert, I reckon I sit there. But shout out to Sophia for flying in last Wednesday and coming to sit with me on Thursday and help me through this on iogas. Hot off the press. So we pulled all the PXRF results into iogas and we filtered them for 1 metre samples that occurred in fresh rock or the sap rock just before fresh. And dominantly using the immobile elements, we determined 5 groupings of rocks. We've classed them as felsic, which is pink, ultramafic, amphibolite, high titanium amphibolite, and a rock that's high chromium, chromium zircon. I do remember Steve Sugden teaching the iogas course, and he said if there's air between the boxes on box and whisker plots, for a good number of your elements, your classification's going all right. So I'm pretty happy with those 5 groupings, because there's a lot of air between those boxes. I think they're quite distinct. So let's look at the felsic group. And I'm doing this one first because it's problematic for me. So generally and relatively speaking, the felsic group's defined by low titanium, cobalt, iron, calcium, zinc, low calcium, and it's higher in silica and lead. It encompasses what we have logged as silica-altered amphibolite without feldspar, along with pegmatite and that granitoid. They have vast visual differences in the chips. I tried to start breaking it down further. This was after Sophia had left, and it was like a rabbit hole. I tried to use the log lithology. I can see some geochemical variations within this overall felsic group. I thought, oh, there's a trend there with a strong positive correlation, and that one's got a weak positive. Maybe if I do, and you can see there's some air between the box plots. But ultimately, then I started looking at fresh rock group with like low CA and high CA granites, and there might be some low CA granites there, but really I'm way out of my league. So I'd like to phone a friend on this one. Steve Sugden, I'm looking straight at you. My option, Steve. Would you like to lock in A, B, C, or D?
Don't call me first.
spoke to you about this. I'll give you a call. So that needs more work, but we'll get there. The amphibolites and ultramafics, they were classified stock standard. So our titanium zircon ratios. But I did break the amphibolites out further. Oh, ultramafic was anything over 1,000 ppm chrome. Categorically, we just put to ultramafic. I think that's pretty acceptable. So the high titanium amphibolite group, I pulled that out because it sits separately. You can see that light green, it just sort of plots away from the rest. And I thought that could be relevant. I should look into that a bit more. So that group, well, it correlated to the logged garnet altered amphibolite. And I went, well, that explains the titanium. Look at me go. And it's associated with the awesome molly that we got at CRAYFISH. Still don't know why the garnets are there. It's really weird. But anyway, let's look at this high chromium zircon group. It's defined by high zircon, chromium, lanthanides, phosphorus, strontium, titanium. And Sophia, in all her wisdom, told me that indicates a deep mantle source. And I was like, really? Excellent. Excellent. Cool. Let's work with that. So I looked up a few papers and she was kind of right. So thanks, Sophia. And when I looked at where we hit it, there's some strip logs. We hit it in the diamond core at CRAYFISH. Awesome. I can actually see the rock. So off to the core photos I go. And it correlates with what we'd logged as the intensely silica flush, moderately sericite altered amphibolite with the 1 to 2% disseminated sulfides. Oh, didn't expect that. So when we reviewed the core, armed with this geochem insights, I looked a bit deeper. I went, oh, there's sharp contacts here. And I don't know if you can see that in the top right of the screen, just at the end or the start of the arrow, there's a nice sharp contact across the core. There's no gneissic fabric within this. There's deformed country rock either side of this for at least 5 to 10 meters. It's quite an extensive deformed zone. Comes from a deep mantle source. It's like, could this be a lamprifier? Texture seems a bit weird for a lamprifier or everything I Googled, but it's certainly an intrusive. So I like to base geology on observations and keep them separate from my inferences because that's good science. So here's some observations. That garnet altered amphibolite, well, that occurred proximal to the deep mantle source intrusive. I wondered if those garnets could be resultant from high temperature contact metamorphism. That would be cool. The felsic population has 3 separate lithologies logged, and you can see it visually in the chips, which I have downstairs if anyone wants to have a look, because I need help. I wondered if that silica altered amphibolite group, if their titanium zircon ratios were plotting all skewed. If you influx a heap of silica and metasomatize it, I was like, that surely should change the ratios. It's not just alteration, we're adding in a heap more fluid. So maybe it's that spread that we saw of that data. We saw multiple generations of pegmatite observed. It was as sills, as dikes, and as veins, yet not much granite logged at Boomerang. I wondered whether the kaolin was resultant from weathering of the pegmatite, because it might explain why the kaolin was so pure, because it really was very good kaolin. And at Boomerang, the amphibolite and ultramafic are spatially associated with the boomerang shape feature in the magnetics. Are those subtle features in the magnetics indicating an amphibolite and ultramafic bedrock? That would be cool. So what about structure? From RC, there is evidence of folding from the logging, and I think from the mags. So I just quickly I back-coded the geology from the IOGAS geochem grouping, and I implicitly modelled it in Micromine. And this is a cross-section through the hinge with the green line representing the top of the amphibolite, or what was categorised as amphibolite. The purple line's the top of the ultramafic, And then there's the brown line sort of at the top is the base of residual hard pan, so silcrete, calcrete. And then in between where I've labelled is the felsic unit. So there seems to be some sort of folding in that way. If we move up the fold, I can see it again. And I didn't quite like how the model had done this because it didn't sort of looked a bit funny in the surface. And I only did this on Monday. But I'd already done it in my head prior because I was like, I can see this when we were drilling. But yeah, actually getting it so I could show you guys and learning micromine. So I've included what I think it might be doing, but who knows? We need more data. These drill holes are 150 meters spaced on the line and 200 meters spaced between lines. So it's quite wide space data. And then if we look west down the sort of along the hinge, we can also see some folding in that direction from the logging. And if Adam were here, he'd say, Mel, did you check this? Because that looks a bit funky. And I'm going to say I did. And it correlates with the fault. And I'm pretty happy with that. So my effort at implicit modelling in a micromine for the first time ever, I'm happy with that result because when it does that, cool. So what about structure from the core? Using the structural measurements that we took from the core, and I had to get creative with toilet rolls and my office with scissors and holding it up. I calculated dip and dip directions of some of the axial planes that were measured in the last drill hole we did down in the south area. And I plotted them up on the hole. And it reflects in the downhole geology. So those points on the drill hole, the green are the amphibolites. So they're back-coded from iogas and plotted them as points, point data, because it was just easier for me to figure out to do in micromine. And the folding could be going something like that I've shown, or it could go the other way. It's probably a bit more work to do there, but I think it reflects in the logging that there's folding there and in the core. So how does it look as we step out in scale? Well, let's project. Thinking those angles are pretty good with that mag feature. And I know, I'm just going to caveat this by saying it's really dangerous to only take a couple of structural measurements from core and project them out regionally. And that would be silly. But I actually already had the interp of this done, and the core happened to fit in with what I had thought. So I would never just take a couple of core readings and project it out. Very dangerous. Could be local variation. We need a lot more data to do that. But if we talk about F1, or relatively F1, fold event 1, from the reprocessed mags, we can sort of trace north-northwest to north-northeast trending fold axial planes through the tenement. And an F1 fold forms the Boomerang magnetic feature. And that tends to match the tectonic foliation in the region. So if we go regionally, these are very generalized trends. Maybe F1s are doing something like that, axial planes. They're probably not in those exact locations, but they're not exactly planar. Well, I'm glad you noticed. Introducing F2. Regionally, they sort of are, by the way, correlate with the demagnetized dikes there, which is interesting. On a tenement scale, they're responsible for the swing in the F1 fold axial plane orientations, I believe, because you can see the subtle features in the magnetics that they loosely mirror each other either side of these. So, observations to inferences. We've got a gneissic fabric observed in the core, and we had oblate chips in the center of the Gulai dome. Note, not on the margins. So this structural fabric's pervasive. It's not just proximal to the Pluton margins. That's new. F1 and F2 axial planes can be traced regionally through the domes. So broadly speaking, these domes have enjoyed the same deformation as the greenstones. Okay, well, that's depending on which paper you read, it's a possibility from the literature. And that beautiful silica-sericite fuchsite alteration we observed, they occurred in the drill holes that run down that axial plane, which I thought was awesome. Related side story. In our first break, one of the geos from Marvel Loch called me up at the house and was like, oh, yay, nice to meet you. It was great collaboration. He offered to take us on a tour of the pit. Brilliant. So we did. One of the pits we visited, so they're the pits we visited with the stars. And I didn't really have time to talk about them all, so I'm just going to talk about the one that really drives the point home. The Kurrajong pit. These are actually just copied and pasted from my Avenza field notes. It looks like they mined along an anticlinal fold hinge with chloratized MAM, amphibolite, in the center and a BIF outer layer. The axial planes trending east-southeast on the east of the pit and southeast on the west. And it's cut by south-southeast structures. So I've sort of drawn that axial plane in red. Back to the story. When I look at Mindex, I can see there seems to be a clustering of gold occurrences where F1 or F2 folds coincide with the greenstones. I wonder if those axial planes, which are renowned for channeling fluid flow, Bruce, Hobbs, thank you. I wonder if the same gold-bearing fluids went through these domes. Boom. When I look at it with Kurrajong, the one that goes through Boomerang potentially strikes straight through Kurrajong. And I measured the orientation there. So I love it when field data works out. So what could it mean? Let's think about some alternate ideas. We have presence of ultramafic and amphibolite causing the subtle magnetic trends that can be seen throughout the Gula Dome. Granites, by definition, have modal composition of 65 to 90% feldspar. Yet there's no feldspar in this granite that we drilled. We have evidence for at least 2 phases of folding, which is consistent with the surrounding greenstones and the overall terrain. We have a later intrusive geochemistry indicating a deep mantle source. We have 104 drill holes into the Gula Dome, which I believe is the most any company's ever done. And only a couple hit anything that resembles a granite. So I start to think, what if they aren't enclaves like they think? What if they're not roof pendants that have been captured in these domes as they've come up? There's a lot of silica in these chips. What if the domes are actually silicified hinges of regional F1 anticlines and they're refolded by F2 to give interference folding, which would give us a really nice dome feature? And there's a lot of folded looking domes on the geology map. I wish I had a pointer, so I'm just going to walk over here. But this one stands out quite nicely, as does this one, this one. Oh, look, I can't not see it now. It's just, yeah, there's a lot of questions, but I'm glad we're starting to ask them. So if you don't believe me, we have a project nearby, Westonia. It's also located in the middle of a granite. The multi-element geochemistry we got shows the subtle features in the magnetics are related to ultramafic and amphibolites. This little subtle feature right here. And boom, we got a 1.85 gram per ton rock sample taken from a mapped axial plane. The quartz vein was trending along it. It was trending 160 on strike. And when I look at that, it strikes straight through Edna May. Boom. Pretty happy with that one. So before we drilled the Gula Dome, we knew it was granite. I think we all knew it was granite or granitic gneiss with dolerite dikes. It was a known known. We took it, we just knew it. Anyone didn't think it was granite? But after drilling, there's more questions than answers. We're in known unknowns or unknown knowns. Probably even unknown unknowns. I just know we're not in the known knowns anymore. Feel like this daily. So on Marvel Loch Airfield project itself, Kula, we plan to get a full in-depth review of the geochem. Thanks, Steve, when you got time. To understand the multi-element results in context of all the other data. There will be a further drill program to follow up that awesome 2.67 gram per tonne gold hit. Yes, not bad for kaolin program at Valentine White, because our drill spacing at the moment, yeah, I can fit a whole world-class deposit between drill holes around that. So here's hoping I do. We might get some thin sections or petrology on the intrusive from a deep mantle source, but ultimately we're going to spend some more time on this and do what it takes to understand the system we're working in. But as a whole, as an industry, as a geological society, as a science-based group that we are, I think we should probably consider this. We need all the help. There's geochronological studies, petrological studies, probably all these fancy studies that could be done and maybe should be done, coupled with a lot more drilling, boots on ground exploration, and all of us questioning the known. But what could this mean? We indicate these domes host potential for many mineralisation types that we, as an industry, categorically don't explore granites for. Granites. We could have greenstone orogenic Archean gold, and I think a 2.6 gram per tonne gold shows that we can get economic grade. Whether we get economic volumes, that's yet to be discovered, but economic grades is a start. We could have copper, nickel, platinum groups, deposits. Did we mention the pegmatites and how much pegmatite was there? Mount Holland's just down the road. I'm pretty sure lithium's hot right now. Mark, is that right? Lithium? Yes. Tungsten moly related to deep sourced intrusives. What about intrusion related gold system type deposits? There's a whole heap of possibilities. Maybe, just maybe, all that ground that's been overlooked might well be worth looking at after all. There's a heap of ground to peg. And maybe, just maybe, a whole lot of pink on the geology map needs to turn green and purple. Just recoloured the Big Bell suite. Thought GSWA might like to do the same. I don't have all the answers, and I don't have the answers, but I have something that doesn't fit the known. And I can tell you what, there's a lot of drill holes we put into that granite, and we didn't hit much granite. In fact, we hit a whole lot of not granite. So, all right, moving on. How am I going to time? Oh, drinks break. Now this one's really quick. I need to present this on behalf of Adam, who's on the plane, and because he was held up in Chile, I put this together today on behalf of Adam. So this is the story of Chile. Well, of the Llahuin project. It's a nice overview of what we've done there with boots on ground exploration. Adam has spent most of the last year working in Chile. He, along with the team he's built, deserve all the credit for this work. And it's a real privilege to tell the story on their behalf. And just as a side note, Adam and I have worked together for 2 years now. And one of the best geologists I've had the privilege of working with in terms of respect and complementary skills. We really are able to bounce off each other. He's got a more geochem met approach, and I'm more mineral systems and structures. So when we get together and actually do the geology, magic. Doesn't happen often, but when it does, we both love it. We're like, we need to do this all the time. So I can't wait for him to land in a few hours. Luckily, Adam asked for me to go over to Chile. So I had the pleasure of spending all of September this year in Chile working on the grounds. It was an amazing opportunity. I'd never worked overseas. And Mark, our chairman for Southern Hemisphere, asked one thing of me during that time, and you probably can't read it, but it says, all good, Mel, crack the code at Llahuin for us and enjoy Chile. Special place, and hopefully turn a seriously large copper deposit for us all. No pressure. So what did we do? We understood the asset. We got our boots on the ground, we went back to basics, and we followed the story the rocks were telling us. The results, they speak for themselves. I'd follow that one on the ASX, by the way, just saying. There's some good press releases come out in the last month and a half. So the Llahuin project, it's an advanced resource stage project, and we're actively working to expand the current mineral resource. It's located in the El Espino IOCG district, and there's 3 large tonnage porphyry targets there. So the Llahuin deposit's the one on the left of that image. Right, I'm not good with my left and right when I'm backwards. The long one. And then we've got the Kalina project just northwest of that, which I'm not really going to cover in this, but they do tie in together. There are 3 large tonnage porphyry targets: the Central Porphyry, Cerro de Oro, and Ferro Carol, which we just call Cerro and Ferro, and the Southern Porphyry. The existing resources at the Central Porphyry, Cerro and Ferro, are 169 million tonnes at 0.4% copper equivalent. These are large tonnage, low-grade deposits. Over 20 kilometres of diamond core and 60 kilometres of diamond and RC to date. Yet the team was struggling to make sense of the existing interp. It didn't make sense. Adam was on the ground and he's going, Mel, this does not make sense. So cue our geoscience driven exploration approach, and we unlock some serious potential. So what did we do? Well, we threw out the old understanding and we started again. The old understanding was previously, each accretionary terrain was treated on its own. So each time we chucked some more mountain ranges on there, the different colours on that, they went, right, we'll just deal with the geology of this group and ignore this one. And we'll deal with everything in this group and exclude the rest. Except that's not how structures work. So we did some research, and I kind of went, well, if this is younger and this is all, this comes on, then whatever happens in this one can affect the previous one, because that's how it works. So we looked at the literature and we noticed this paper by Solito, which said there's northwest and northeast trending metallogenic domains, which span the whole country. And that matched observations made by Adam. And he told me that in July. I remember I was in New Zealand. He's like, Mel, there's a clear northwest trend on this. And I was like, oh, cool, that helps. We've got somewhere to start. So we could see this trend. And so we kept this idea in the back of our heads that maybe we're looking at structural domains. We got our boots on the ground, and it was brilliant because we were on opposite time zones, and I've never felt the joy of my phone not ringing every 5 minutes. I recommend it to everyone. We were able to do some really good work because, we were focused. So we quickly realized the existing data that we had did not reflect the observations on the ground. The previous work had assumed a bulk tonnage porphyry deposit, and it was explored for, drilled and logged according to a bulk tonnage porphyry deposit, where these small things are not important, except there's clear structural control and mineralisation which needed to be taken into account. We questioned everything: the drilling, the sampling, the logging, the interp. We implemented some data management. Those photos, they're pretty accurate representation of the data as well. Like that was the core yard. The data being captured at the time by the current geologists was also not consistent. So one geo was using one method, another one was using another. So to actually use the data itself was very confusing and time consuming. Sorry, yep, I'm wrapping up. So we fired the core shed manager, the goat. And we started to put some organisation in place. We can't use the data in the future. It's not worth the time it took to capture it. Bring in GDB, and they helped us sort it right out. So they worked with the unique internet and language barrier challenges that we had with working with people who speak Spanish and we speak English. And we found effective solutions that could get our data into the database. And this resulted in having reliable, accurate, and consistent sample data. And we got it in real time, meaning the copper results from PXRF from one day are literally used to define where we're sampling the next day. The ultimate result was accelerated ability to advance the interpretation. Low-cost exploration with a huge value add. We started geological reinterpretation. That 20 kilometres of historical core, yeah, we're about 85, 90% the way through relogging it. And it's recognised a breccia system that's previously been overlooked. We're capturing the structures, mineralisation and timing relationships. And this is what the core looks like. Like it's quite stunning. We generated our own data set from soil sampling, extensive areas, geological mapping to capture required data, along with rock chip sampling. It was and is an ongoing iterative process. But the advancement in understanding over the past 8 to 10 weeks, or the first 4 weeks that I was there and continued, I can't keep up with it now I'm back in Perth. Like, join the weekly and I'm like, whoa, what happened now? Whoa. The geophysical data that was acquired in 2019, it had limitations, and this is actual photo from the survey. So you can imagine the limitations of that data set. So we thought it prudent to acquire some more. This was done in 2021. There was high-res drone mag done, IP survey, and ortho photos. It's allowing the historical data to be correctly positioned in space, the high-res ortho photo, and integration of the geophysics data with the observable geology helps us to consistently evolve the interp. So what are the results? Relogging of the available diamond core revealed a significant proportion of the copper gold mineralisation is hosted by a large hydrothermal breccia system. And it's identified a previously unrecognised bornite-bearing system. Mapping and interpretation confirm the breccia system is hosted by the overall northwest trending corridor with sinistral kinematics, which allows us to target our exploration along the structures and corridors considered more prospective. Which ones are dilating at the time of movement or at the time of mineralisation. And using this, we've got a recent rock chip result of 9.13 grams per tonne. Let's not forget the deposit grades are 0.4 copper equivalent. This is huge. The ortho photo allows us to delineate new zones of prospective alteration for testing with the soil sampling because you can see them on the ground. We upgraded the infrastructure. We now have a fully functional site office with satellite internet, power, water and toilets, core storage facility with more than 10 k's of core we could still store, and all the pulps from all the historical drill samples are organised and accessible. The soil samples have defined a substantial north-south trending plus 800 ppm copper and soil anomaly based on a 1 mil sieve. And this is one of our favourite bits. We have determined that Chero and Ferro are linked. We've got the soil anomaly is 1.9 kilometres long by 300 metres wide of plus 800 ppm copper in soil. The peak soil value of 1.4% copper, like almost 4 times the deposit grade. Around half of this area remains to be drill tested. There is some drilling in the areas that is not soil sampled on the map. The copper in soil anomaly is coincident with the north-south oriented zone of advanced argillic alteration that's visible on the ground and in the ortho photo, which supports our targeting approach to use the aerial imagery to map out the alteration zones. Another low-cost exploration method with a huge value add. Geophysics. Well, the IP survey advanced the potential of a deep IP target to the east of the current drilling at the central porphyry. It remains untested by drilling, and we're currently doing further work on this. But before we did this new interp, these new magnetics made 0 sense. In fact, Adam was like, I don't know why we bothered. They make no sense at all. But in light of the new interpretation, we looked at it again, and poof, they make a whole lot of sense now, and they're actually really useful. We're using them to assist us to build the structural architecture of the system, as we know that that controls ultimately the mineralisation. And it provides us insights when we're interpreting the surface data at depth. So currently we're expanding the exploration to demonstrate the scale potential at Llahuin by targeting soil samples with infill soils as necessary. We're targeting mapping and rock chip sampling, and then we'll move on to drill target definition and ranking. At the Central Porphyry, Chero and Ferro deposits, we're working towards development of a revised geological model by the relogging. We also are going to map the sulfides by using PXRF on the historical drill pulps. We're going to map those in 3D and use that to assist us to vector into a potential deep source or feeder zones. And the additional benefit of that is we will generate a large multi-element data set, which we actually don't have at all. So pathfinders, all this interesting geochem is about to be available at our hands. And we can't wait to build that in to the interp. We're still working through the challenges. We're honing procedures, testing theories, and developing ideas. However, in the month I spent in Chile, magic happened. Collaboration, respect, and hard work saw us turn this project around. And all we did was went back to basics. We questioned everything. We got our boots on the ground with a clipboard, a map, a compass, a geopic, and a hand lens, and we looked at the rocks. We threw out the old interp because it didn't fit the observations. We implemented consistent, accurate, and transparent data capture and data management processes. And we involved the whole team by training and upgrading their skills. We're trusting our new geoscience-based observational data to develop and evolve the interp. We understood the asset by developing an interpretation that makes sense with observations made on the ground and in context of all the other available data. And as scientists, that's what we should aim to do every single day. So now we've got a new problem. I don't know which target to drill. And that's Llahuin. Watch this space. Thanks, guys.